Example is palindrome. So now we're going to see one problem that uses the techniques we just covered, and that is determining whether or not a string is a palindrome. A string is a palindrome if it's the same forward as backwards. And so one way to do this is to include our reverse string function that we just wrote above. We saw reverse string right up here in reversing a string. If we do that, we can test if a string is a palindrome, just seeing if it's equal to the reverse of itself. This test right here is a really clean test to determine if a string is a palindrome. It's a little bit wasteful because we're creating a new string and we really don't have to. We can take the existing string and without creating a new string, we can go through and test the characters individually, which would be more efficient. But nonetheless, this is very clear and not bad at all for a novice programmer. The second way to do is palindrome, and I should note these are only several ways. There's many ways to do this. We're only presenting a few. For any problem you're going to attack in this course, there's going to be an abundance of very good and maybe sort of good and some quite not so good solutions. There's no one way to solve any problem. In any case, here we'll go through the string and we'll start when I is 0 and compare the 0th character, that is the one on the left, with the len of s minus 1 character, the one on the right. Compare the one on the left against the one on the right. If they're different, that's it, we're done. Otherwise, continue. I will become 1. Compare s of 1, the second from the left, to s of len of s minus 1 minus 1, len of s minus 2, the second from the right. Then the third from the left against the third from the right, and so on all the way across. We go all the way across the string, and if we get no matches, then sure enough, it's a palindrome. This works, and in fact, if you're clever, you could stop halfway across, which would not be a big savings, and you have to be careful how you do it, but indeed, you could have that small optimization. isPalindrome 3 is really the same as isPalindrome 2, but it's dealing with negative indexes, so all we did was drop, all we did was drop the len of s right here. There we go. So we got the minus 1 minus I, minus 1 minus I, dropping the len of s, because this is a positive index right here, and this is a negative index, but they're referring to the same character, so these are really the same. isPalindrome 4 is pretty funky because what it's doing is it compares the first character against the last character. If they're different, go ahead and just say that's it, not a palindrome. But what if they're the same? We construct an entirely new string, which is the string we had starting at the second character, because remember s of 0 is the first character, and going up to and not including the last character. So if we start with ABCBA, this test will compare the A against the A, and they do match. So then it'll set S equal to that string there, BCB. And we'll continue in the while loop so long as we have a string greater than 1. So the B's match on BCB, so it'll turn into the string C. Since C is only one character, we'd stop at that point, and we'd go ahead and return true. This works, but it's extremely expensive because it's constructing string after string after string. So I would say this is the worst way, in my opinion. These are probably the most efficient way, but number one has to be considered a pretty good option because of the tremendous clarity involved. And now when we test these, and these are not thorough tests, but they're meant to show whether they work at a high level, we go ahead with an actual palindrome and a non-palindrome, and we see that all 4 versions work the same way as expected. And that completes our example of isPalindrome.